In this video, we're going to take a look at adding and subtracting algebraic fractions. Now, for adding and subtracting algebraic fractions, this works in the same way as just adding and subtracting regular fractions. So what I mean by regular fractions here is if we've got, say, something like 2 over 3 plus 3 over 5, something you're more familiar with, okay? Now, we couldn't add these yet, and the reason for that is because we don't have a common denominator, okay? And this is true for algebraic fractions. So we can add or subtract algebraic fractions unless they have a common denominator, okay? Now, what we normally do here is we'd say take this left-hand fraction here and we times it by the opposite denominator. So we times that by 5, okay? And then we do the same with this right-hand fraction here. So we take this 3 over 5 and we times that by the opposite denominator, which is 3, okay? And we're going to repeat that now with algebraic fractions. So if we take a look at this first one here, we're asked to write as a single fraction in its simplest form, 1 over x plus 3 plus 2 over x plus 4. So what I need to do here is get a common denominator. Okay, when we look at these fractions here that we're adding, they're not over a common denominator, so we need to do a bit of work here. And what I'm going to do is I'm going to take this left-hand fraction and times that by the opposite denominator. So what I'm going to get then is 1 lot, so 1 lot of x plus 4. Okay, so we're timesing top and bottom here by the opposite denominator. And then in my denominator here, what we get is a product. So I get x plus 3, so x plus 3 times x plus 4 there. Okay. And because we want the answer in its simplest form, it makes sense here just to keep this as a product rather than expanding it. Okay. So that's the left-hand fraction. If we take a look at the right-hand fraction here, again, we just repeat this now. So what I'm going to do, I'm going to times the numerator and the denominator by the opposite denominator. So that's going to give me plus 2 lots of x plus 3. So 2 lots of x plus 3. And again, this will be over this product here. So x plus 3 times x plus 4 there. Okay. Now, because these are over a common denominator, we want to write this now as a single fraction. So what I'm going to get here is a single numerator, which is going to be 1 lot of x plus 4 plus 2 lots of x plus 3. Okay, so let's simplify this here. So 1 lot of x plus 4 is just simply x plus 4. And then I've got 2 lots of x plus 3. So expand this here. So I'm going to get 2 times x, which is 2x. We get plus 2x. And then finally 2 times 3, which is 6. Okay, so we get 2x plus 6. And our denominator here, we just keep this as a product. Remember, we don't expand this. We want to keep it in its simplest form. We'll write that as x plus 3 times x plus 4. Now, what we have done here is expressed it as a single fraction, but it's not in its simplest form, because notice we can now simplify the numerator, okay? So do make sure that you do simplify the numerator. So I've got x plus 2x, so all we're doing here is now just collecting like terms. So x plus 2x gives me 3x, and 4 plus 6 gives me 10. So we get 3x plus 10 as our numerator, and then don't forget your denominator here. So I'm going to get x plus 3 times x plus 4 there. Okay, and there we have it. So that's our single fraction in its simplest form. Okay, and that's our solution to the first question. So what I'm going to do here now, just so we've got enough room for the second one, I'm just going to clear the screen. So for this one here now, what we're doing is we're subtracting. So I've got 5 over x minus 1 minus 1 over x plus 5. And again, for subtraction, we need a common denominator. So all I'm going to do here is take the left-hand fraction, times that by the opposite denominator, and do the same with the right-hand fraction. So what I'm going to get here is 5 lots of the opposite denominator, so that's x plus 5. So 5 lots of x plus 5, and this will now be over x minus 1 times x plus 5. Okay, so x minus 1 times x plus 5. We now minus, so this is going to be a minus, 1 lot of the opposite denominator. So that's minus 1 lot of the opposite denominator. And again, it will be over the same product here. So x minus 1 times x plus 5. Okay, like so. Let's just simplify here. Now, because we've got this over a common denominator, we can write this now as a single fraction. So what I'm going to get here is 5 lots of x plus 5, so that would be 5x plus 25. So just expand this bracket here. So we get 5x plus 25. Now, be very, very careful with this second part here. So what I've got now is minus 1 lot of x minus 1. So be very careful when you expand this. So minus 1 lot of x minus 1. If we simplify this here, so expand this, I'm going to get minus x. That's minus 1 times x, giving me minus x. And then minus 1 times minus 1, which will give me positive 1. So this is where you've got to be very, very careful. We get positive 1 there. Okay, so that's 5x plus 25 minus x plus 1. Okay, and this will all be over now, this product here. So x minus 1 times x plus 5. Okay. Now again, we want to give this in its simplest form. So all I need to do now is collect like terms where possible. Well, the only place we can now do that is in the numerator. So I've got 5x minus x, that will give me 4x. We get 4x there. And I've got 25 plus 1 giving me 26. Okay, so we get 4x plus 26. And don't forget our denominator here. It's not much of a fraction. Without the denominator, I'm going to get x minus 1 times x plus 5 there. Okay, and that's our single fraction now in its simplest form, giving us our solution to the second question. And if we move on to the very last question here, all we want to do is write as a single fraction again in its simplest form. So I'm doing x squared over 3 plus x over 5. Now the real difference here is that our algebraic expressions are now in the numerator, okay, rather than the denominator like we saw with the previous two questions. However, this doesn't change anything. Remember, we do need a common denominator, just like we've seen with the previous examples. So again, I just need to get a common denominator here before we can add these together. So in this case, I'm going to take the left-hand fraction, times that by the opposite denominator, which is 5. Do the same then with the right-hand fraction. So I'm going to take this fraction here and times it by the opposite denominator, which is 3. So what I'm going to get here, hopefully nice and straightforward, is 5 times x squared. And then we do the same with the denominator, so that's going to be 3 times 5. So we get 5x squared over 15. So 5x squared over 15. Do the same now with this right-hand fraction here, but this time we times it by 3. So that's going to give me plus 3x over 15. So all we need to do now is basically put this over a single, or write this as a single fraction. That's going to give me 5x squared plus 3x. And this is all over 15, so we can write this as a single fraction because they share a common denominator. And there we have it. That's actually our solution, and it's already in its simplest form. Okay, so there we have it. So that brings us to the end of this video on adding and subtracting algebraic fractions. In the next video, we're going to take a look at multiplying algebraic fractions.